When using a prosthesis, it's important to have a well-fitting socket because the skin on the residual limb is very sensitive, and if you have an ill-fitting socket, this can lead to skin irritations and open wounds that can ultimately leave room for life-threatening infections like sepsis. So there are good solutions in developed areas for creating customized, well-fitting sockets, but this requires many appointments over many months with very skilled prosthetists. And these are things that just aren't available in low-resource areas. So some current solutions in low resource areas, what you'll notice about all of them is that they commonly use recycled or repurposed materials. So one example that you can see here is a residual limb protector, and these are commonly made out of recycled tires. What is really in need is a method for creating customized prosthetic sockets in low resource areas that reduces the amount of materials that are required, reduces the time that's needed for manufacturing, and reduces the skilled expertise that are needed to create these prosthetics.
Unfortunately, ongoing military efforts in regions of the world still littered with explosive devices have created the harsh reality of a multitude of traumatic amputations within the local civilian populations. While they can initially receive their initial stabilization surgery in the military hospitals, their follow-up prosthetic needs are often done in the local economy. It is here where we see a multitude of morbidities and mortality associated with improperly fit makeshift prosthetic devices. As such, there's an immense need for a robust individualized prosthetic socket and device in the developing world.
We wanted to come up with a method of manufacturing a well-fit and well-designed prosthetic in a low-resource environment, particularly with the goal of minimizing the amount and complexity of the input resources needed to do this. And so we developed 3D Phase. 3D Phase, or photogrammetry high-fidelity automated scanning equipment, is a device that is entirely 3D printable. It's easy to use, it's durable. 3D Phase is a device that will utilize a cell phone, and it will rotate it and translate it about a limb to take a bunch of photos. And then those photos get sent to a photogrammetry reconstruction program, which will use them to reconstruct a model of the limb. That will give us the 3D topography of that limb, which can then be sent to a prosthetist. And a prosthetist can identify points of pressure, and they can manipulate that model to create an optimized socket. This file can then be sent back to the base, and the prosthetic socket itself can actually be 3D printed and then utilized ready for use in a prosthetic. This model can be subtracted from a cylinder to create a socket, essentially, which can then be kind of molded into the optimum shape and then 3D printed.
Through utilizing the phase device as well as the techniques associated with additive manufacturing, we feel like we can turn this ongoing need into a tangible reality.